Good morning, students. Today I am here to present a topic, photonic integrated circuits and applications. This is a new field for you because you are used to what is known as optical fiber communication. Let me just go through the overview of the presentation. The overview of the presentation is as follows. Introduction to fiber optics. Then I will be telling about the photonic integrated circuits. Overview of the PIC technology, how the technology is, what are the devices, what are the requirements of this technology, and then I will cover some applications in this domain. Now, before the invention of the photonic integrated circuits, the optical fiber communication had taken a stand. So what is optical fiber? Optical fiber is a flexible, transparent fiber which is made up of glass or plastic, and the diameter will be even slightly thicker than the human hair. We all know that. And it's a very efficient medium. Now, what is the basic structure of the fiber? We will just go through. So as you can see, there is a core and clad and coating. Coating is for the protection mainly. The core and the clad differ with respect to the refractive indices. The highest refractive indices will be there in the core region, and the clad region will have a lesser refractive index as compared to the core. The basic principle of this optical fiber communication is based on propagation of the light inside the core of the fiber. As you can see that the fiber core, inside the fiber core, we will see that the total internal reflection, which is commonly called as TIR, will take place. Now, what is this TIR? So if you just look into the TIR, we have that when there are two media, different kinds of media, you can see that the two different kind of media here are core and clad. So what is the core refractive index is usually higher. So always the light will propagate from refractive index of higher value to the refractive index of the lower value. We can see that the light is propagating from a region of higher refractive index, which is called as a denser medium, to a region of the lower refractive index. When it is happening so, you will see that at a particular angle of incidence, the angle of refraction is 90 degrees. This particular angle of incidence is called as the critical angle. So any other angle of incidence for which the angle of incidence is greater than this critical angle is called, will make the total internally reflect back to the core region. So this is what is happening in the TIR. So almost all the rays which hit with the angle greater than the theta c will be reflected back to the core, and they will propagate inside the core region. Now, usually an optical fiber communication is the most common type of communication in which you have light propagation that is taking place. So light is a lot of benefits are there. We will just go through why we have to go through the OFC is preferred rather than other types of communication. So usually, as you see in the block diagram of the OFC, we have first the source of information, which can be any kind of data that will be electrical in nature, electrically transmitted, and that has to be converted into optical domain because it has to transfer or propagate through the optical fiber. So there is a conversion that is taking place. You have electrical to optical conversion that is happening. And then once it is converted into light, an example is LED, which can be used. It converts the electrical signal to optical signal. Then it is going to be passed over the optical fiber cable, and then it reaches the destination, that is the receiver. In the receiver, we have the conversion back to the electrical signal, that is light gets converted to electrical form using the photo detector. A good example is a photodiode, and then it gets to the destination. So all these stages will be usually there in any normal OFC communication blocks. So what is that which makes the OFC great as compared to other kinds of communication? So the main advantages of the optical fiber is that it has got enormous bandwidths, low transmission loss, immunity to crosstalk, electric isolation, small size and weight, signal security, ruggedness, flexibility, and low cost and availability. The enormous bandwidths, because it is having a very large frequency range. The frequency, usually we call it in wavelengths only because the frequency is in the order of terahertz. So it can carry large bandwidths. Gigabits of data can be, I mean, even nowadays you have terabits of data that are getting transmitted. And when you have a low transmission loss, because the loss is not much in the optical fiber, only due to the irregularities in the glass or the material that is being used, you may have some loss. And there is always an important property is that we have immunity to crosstalk and electric isolation. So there is no electromagnetic interference when you try to use an optical fiber. That is very important for us. And because nowadays you have EMI, that is the electromagnetic interference. So this is not at all there in the optical fiber. And it's very difficult. Signal security means it is very difficult to tap the information that is there in the optical fiber, because if you simply cut the fiber to tap the information just like a copper cable, the transmission is lost simply. You will not be able to get anything out of that fiber once it is cut. And of course, low cost because of the availability, easy availability of the sand or silica that is used in the manufacture of the fiber. So these are the few applications of the fiber optics. So you can see that it is being used in medicine, military and communication, sensor and structural monitoring.